Alright, so today we're going to go over stacks in computer science. So a stack is a data structure that we use to represent data. Pretty similar to an array, but we restrict it in some way. We're basically it's going to be like a regular array, but we can only modify this last element. So why would we do that? We add restrictions to basically give a template for how to interact with the data structure. So this is an idea in programming called encapsulation, where we only give the programmer data that they need to know. So in other words, if you had some algorithm that only needs to manipulate this last element of the array at any given point in time, then we need to make a data structure that respects that, so that we don't accidentally modify something we're not supposed to. And a stack has 3 operations on this said last element, and it's going to be the push, pop, and peek. And we'll get into what those mean in just a second. And stacks are very efficient in certain kinds of problems, especially maze solving algorithms and function evaluations. So just to jump right into it, for the operations that a stack has, the first one that we'll go over is the push. So in a stack, you can always add another element. So let's say this is 1, 2, 3, 4, and then we can just add another element to the list. And this is our new last element, and now all these other operations that we're going to go over are going to manipulate this element that we just added. So a stack also has an operation called pop. So whenever we pop an element in a stack, we're removing the very last element. So in this example, this element right here. And that's pretty much all there is to the pop. You can only remove the last element though. You can't remove, for example, this element right here or this element right here. In general, for a stack, random access is not allowed. You can't just access any element you want, insert it any place you want, remove any place you want. You can only operate on this very last element. Now for the last operation, the peek, the peek is basically just returning the very last element of the stack, but it does not remove it. And like I said before, random access is just not allowed. And the reason for that's, like I said before, to encapsulate data, and we can only modify things that we have permission to. And all these operations are going to be O of 1. So in other words, all these operations, the push, pop, and peek, they're going to operate in O of 1 time or constant time. Because whenever we do the peek operation, this element of the stack, so that would be constant time. And pretty similarly, if we just insert an element, we're just going to the current last element and adding another one. Since we're just adding one element, that would be constant. With the pop, if we're popping the element, so in other words the very last element, then we just access that element and then remove it. Now these are all theoretical runtimes. Whenever you have a list or array that can grow in size at any point in time, practically speaking, there's a certain amount of memory that array has, and whenever it reaches that limit, it has to allocate more memory. So let's say this right here, this array right here has, at this moment, 6 spaces for elements to be in. Whenever we try to add this 7th element, we're going to need to allocate more memory for this. And that's whenever the push method is going to not run an O of 1 time. But theoretically speaking, these operations all run an O of 1 time. So now for the applications. So backtracking and maze solving algorithms can utilize stacks. So let's say we have a graph that looks like this, and then all of these nodes also have other ones too. So in other words, these nodes can also branch off however they want, and we want to figure out the most efficient way to get from some node to another one. So let's say all these nodes have a certain weight that it takes to travel to. So to get from here to here, 1 day or something like that. And then this maybe takes 2 days, 3 days, whatever. And we want to figure out the best possible way you can get from point A to point B. So what we would try to do is use some sort of heuristic to solve the maze. So in other words, we would look at all the different possible paths we could take right now, and then we would form a stack that looks kind of like this. So we would put our what looks like the worst entries first. So for whatever path that is, I'm not really confident that's going to give me the best answer. So then I would add them in the stack like this, where this is the first element and this is the last element of the stack. So I would try to solve the maze going from this position first, and then maybe that gives me a bad answer, so I pop that element and then go to the next one, and I would basically repeat this process until I've exhausted all my options. Alright, so for the next one, evaluation of functions. So let's say we want to evaluate some function f of g of h of x. So to put this in terms of a stack, what we would do is, so we need to evaluate f of all of this. So we would put f at the top of the stack, and then to evaluate f, we have to evaluate g of h of x. And to evaluate g of h of x, so we put this in the stack, and now we need to evaluate h of x. And then so h gets put in the stack too, and then x. But for any given input x, we know what x is. So we would then return that value and pop it from the stack. And then we go here, and then since we have that value from here, we return h of x and pop it from the stack. And then we repeat the same process up here, so we know what h of x is, and then evaluate g of whatever that output was, and then return it and pop that element. So we would do a peek and then a pop. And then right here, we know what that output was from this node. So then we return f of whatever that output was, and then pop it from the stack. And then whenever the stack is empty, that's our answer. And then another application, so if you're trying to minimize something or maximize something, you can use this heuristic that I mentioned earlier. So if you're trying to maximize some certain quantity or quantity, then what you can do is heuristically arrange your elements like this, so all your different options, and then you have your better options at the back of the stack, so that you evaluate those first and then work your way up. Alright, so that's it for today's video. Let me know if you enjoyed it. Let me know if you have any questions down in the comments. See you in the next video.